Let's begin to construct portfolios, but let's start with baby steps, with combining a risky asset with the risk-free asset. So something, an investment, an asset that's completely risk-free. And let's see what we're gonna get before we move on to combining multiple risky assets, which is more complicated. All right, so the math of this is pretty simple. But so first of all, by the way, what do you mean by the risk-free asset? Imagine the least risky investment you can make and you can put in your portfolio. Think of, for example, very short-term default risk-free, very low interest rate risk investment, which would be lending to the US Treasury for a very, very short period of time. So for example, think Treasury bills, right? So it's not perhaps completely 100% risk-free, but it's really, really close because the US Treasury is highly unlikely to default, especially in the very, very short term, and even interest rate risk, because we know these short maturity bonds have very low duration, so interest rate risk is very small as well. So this is as close to risk-free asset we can get. Going forward, when we need this benchmark rate, the risk-free rate, is going to capture time value of money. And so it's going to be very important for us. So in different contexts, we may use different maturity US Treasuries. So in one place, it may be more appropriate to use the 1-year Treasury T-bill yield. In another context, it may be more appropriate to use the 10-year T-note rate yield as the risk-free asset, but that's for later. So what's going to be important here when we are combining a risky asset with a risk-free is risk-free implies its sigma volatility should be 0. So when you buy something, one of these things, if you hold it until maturity, you know exactly the return you're going to get. So around that expected return, which will be pretty small because again, no free lunch, low risk means low return. So the expected return will be pretty low, but that also means it's guaranteed, right? You know, if you buy a T-bill, we know from earlier chapters, you buy it at a discount, for example, $98.5, and it's going to pay $100 in 3 months. You know exactly you're going to get $100 in 3 months. There's absolutely no uncertainty. So that what it means, sigma is 0. And what that does is now starting with portfolio return, it's just weighted average of 2 assets. Weighted average, portfolio weight of A, so that's the risky asset, say asset A, times its return A, plus, now let's say lowercase f is the symbol we use for risk-free asset, all right, so it stands for the free F, so lowercase. WF is the weight on the risk-free, so how much of your money are you using to buy those T-bills, times the return on those T-bills, which you know for certainty, guaranteed, you know exactly how much you're going to get, okay? So portfolio return, just weighted average of the 2 returns. Portfolio volatility, following from the previous formula, the volatility of a 2-asset portfolio, but what's going to happen is 2 of the 3 terms in that volatility formula have sigma B. So if you say the risk-free asset is B, sigma is 0, guaranteed, right? So those 2 terms fall out, and then we are left with square root of W weight A times sigma A squared. So square root and square cancel each other out, and we are left with portfolio volatility is equal to just the portfolio weight of the risky asset times the volatility of the risky asset. So the problem really simplifies when we have one risky asset and one risk-free asset. Okay, so let's see an example. What does that look like? Example, you expect an annual return of 9% from Microsoft with standard deviation volatility of 30%. So that's our risky asset. And this is sort of what we are expecting, right? 9%. And there's quite a bit of amount of uncertainty surrounding that. Things can go great. We can have much more than 9. Things can go terribly wrong and we can get lower than 9. So that's quantified by 30% volatility. Now, the risk-free asset is offering 0.5% annual return. So maybe think about like a 3-month T-bill or a 1-year T-bill. It's guaranteed return. So sigma is 0, but the return we would get is 0.5%. So now we're going to form a portfolio. What's very important in forming portfolios is portfolio weight. So we're going to talk about all right, how much money are you investing? How much of it are you going to put in Microsoft? How much of it are you going to put on the risk-free asset? So buy T-bills with it. So if you have $40,000 to invest and you buy $30,000 worth of Microsoft and $10,000 worth of the risk-free asset, what are the expected return on volatility of your portfolio? Okay, so for both of these, we need a portfolio weight. So let's start with figuring out. So whenever you have portfolio construction problem, figure out what the portfolio weights are. So let's start. We can pick either one, but let's start with Microsoft. Portfolio weight of Microsoft equals amount invested in Microsoft, which is 30,000, divided by total amount invested in the portfolio, which is 40,000. So that's 0.75, 75%. Because the weights have to add up to 100, we don't even need to compute the portfolio weight of the risk-free asset. It's just 100 minus that. The remaining part is 25%. Okay, so this is going to dictate our portfolio return and our portfolio risk, right? We would get a completely different picture if we were putting 50% on Microsoft and 50% on the risk-free, or 10% on Microsoft and 90% on the risk-free. So the higher the portfolio weight on the risky asset, the riskier our portfolio will be and greater our expected return will be. The lower the portfolio weight on the risky asset, the lower our return will be, but in turn, the lower the risk will be. So that's exactly what we're going to see, right? Portfolio risk, portfolio return, RP, is going to be the weighted average. Weight on Microsoft, 0.75, times return, expected return on Microsoft, 9%. Plus weight on risk-free asset, 0.25, times expected return on the risk-free asset, 0.5. Take the weighted average, simple calculation. The return we expect from our portfolio is not surprisingly somewhere in between the two, closer to Microsoft, because we are putting more of our money in Microsoft. We get 6.875%. Okay. But we are doing this. Why are we doing this? We are doing this because presumably, we don't want to invest 100% in Microsoft. Maybe it's too risky for us. So we are putting some in the risk-free asset. That's reducing our expected return, but also reducing our risk. So let's see the reduction in risk component now. Sigma P equals just the weight on the risky times the sigma of the risky asset. Remember from the previous slide. So weight on the risky asset is 0.75 times its volatility, 30%, 22.5. Okay. So if Microsoft on its own 100% with 30% volatility is too risky for you, put some of your money in Microsoft, some of it in risk-free, so you reduce your expected return a little bit, but you also reduce your portfolio risk. So there's less uncertainty surrounding that expected return now. If this is even too risky, you pull it back, you put even less on Microsoft and more on the risk-free, and you're reducing your uncertainty more and more and more. Okay. So that's what one risky portfolio with one risky asset and one risk-free asset looks like. Now let's plot this. So this is going to be very important because when we're talking about portfolios, there are going to be a number of very important charts and figures. So we are starting our very first one, risk versus reward, right? So let's visualize risk versus reward. Actually, what we're going to do is reward versus risk. So return versus risk. For the time being, our risk measure is going to be sigma, volatility. Okay. So what we're going to do is this is what it's going to look like. Y-axis is the return. And this can be, for example, you may be plotting historical returns, or you may be plotting your subjective expected returns. That's on the Y-axis. The higher, the better, of course. And on the X-axis, horizontal axis, we have our risk measure, which at this point is still sigma, volatility. All right. So what we're going to do is, remember, we have our Microsoft and we have our Tesla, and we have our risk-free asset. So far we have 3 assets. So let's put them on this graph and let's see what this looks like. Right. So let's start with Microsoft. Remember, Microsoft, we had said expected return is 9% per year. With volatility, uncertainty surrounding that, 30%. So we have 9% on the y-axis and 30% on the x-axis, and the intersection is Microsoft. That's the point. That's our data point. That's where Microsoft is, and it's the risk-reward relationship for Microsoft. Now, if we put Tesla, it had 12% expected return and 60% volatility. with uncertainty. So the intersection of that is where Tesla is. So these are our two risky assets that we have, right? So now in these reward versus risk, just keep in mind the top left is the good part, right? Because that's where you have a lot of return with low risk. So if things are there, that's pretty good. You are getting high return, high reward with low risk. Whereas the bottom right, that's very high risk, high volatility with very low reward. So that's bad, right? So you're not getting as good a risk reward sort of trade-off from there. So keep that in mind going forward. So now let's introduce our risk-free asset, because this is going to be important. We already start to create these portfolios with one risky asset and one risk-free. So this is our risk-free is set 0.5%. It's not to scale there. I just put 0.5 there for just demonstration purposes. But what's important there is sigma is 0, right? So the risk-free asset, it has 0 risk, but also then it has low expected return. So now remember our portfolio risk and portfolio volatility formulas. Those are actually on this reward versus risk graph. They constitute a line. So they are straight lines. So whenever you form a portfolio with a risky asset and a risk-free, the resulting portfolio risk and return will be given by a line. And where you are on that line will be dependent on the portfolio weights. So this is what Microsoft example from the previous slide actually looked like. That straight line that connects Microsoft with the risk-free asset. All the possible portfolios, potential combinations of risk-free asset and Microsoft are on that red line, okay? Depending on the portfolio weight. If you put 100% on Microsoft, you are on Microsoft. If you put 100% on the risk-free, you are on risk-free. Anywhere in between, you're going to be on that red line. Previous slide, we had 75% on Microsoft. So we were like 3/4 of a way towards Microsoft. And that's where volatility was. And that's where the return, expected return were. Okay. So keep this in mind. Risk versus reward. We have our risky assets. And then all potential portfolios, when you put a risk asset with a risk-free asset, is on the line that connects the two. We could have done the same thing with Tesla, right? Without doing any of the math, all potential portfolios of a Tesla with the risk-free asset will be on that straight line that connects the two, okay? So now what's interesting here is if you think back to our previous video about risk reward, and when we introduced the Sharpe ratio first, remember the formula for the Sharpe ratio, right? Expect return on an asset over the risk-free rate divided by volatility. That formula, that number, Sharpe ratio, is actually the slope of the line connecting a risky asset or portfolio, whatever that point is on the risk reward on that chart, with the risk-free asset. So that red line, the slope of that is the Sharpe ratio of Microsoft, and the blue line, the slope of that is the Sharpe ratio of Tesla. So it's giving us sort of this risk reward number. Remember what Sharpe ratio was? How much upside do you have for the amount of risk you're taking? Well, that's the slope of that line of all portfolio possibilities, combining that risky asset with the risk-free asset. Okay, so this is important. Now we had said, remember in an earlier video, with the numbers that we used, we had said Microsoft's Sharpe ratio is greater than Tesla, and that's visually we are seeing that here. It's steeper, right? With Microsoft, we are getting more return for each unit of extra volatility we take on. We are getting more reward. That's what a higher Sharpe ratio means, and that's what a steeper slope means. That's what we had concluded.